Okay, 1 minus u squared, all of that cubed, right? 1 minus u squared, all of that cubed. And then cosine x dx is just du. Everyone follow? Any questions? Y'all sure? I keep asking. No one has questions. Everyone's just, this is all okay? Okay. All right, now unfortunately, we've got to figure out how to handle 1 minus u squared cubed. That's not something just straightforward, right? We're actually going to have to cube that. So I'm going to do that as scratch work right here. What's 1 minus u squared cubed? Well, it times itself, right? 3 times. And there's formulas. Maybe you've learned them to do this, cubing things, but I'm just going to do it brute force by hand. So the way I like to cube things is I like to leave the first one alone, and then I like to actually multiply those out. So I'm going to FOIL those, all right? I'm going to FOIL those, but I'm doing do that foiling in my head, all right? It's going to be 1 minus 2u squared plus u to the 4th. I've already done it, and I've collected like terms. Is that fair? Leaving that step out? Okay, now to do this, I multiply the 1 through to everything first, and then I multiply the negative u squared through to everything, and that'll be done. So when I multiply the 1 through first, I get 1 minus 2u squared plus u to the 4th. Then I multiply negative u squared, so negative u squared goes here to here. Positive 2 what? U to the 4th, and then last one, minus u to the 6th, right? We're adding exponents there. Collect like terms, and we'll be done, right? If I collect like terms, I've got 1 minus 3u squared plus 3u to the 4th minus u to the 6th. That is the expansion of that. That's what my integral is. And can't you do those one by one? If you find yourself sitting here today, and especially next class, saying, do we really have to go through all these steps and work? Yes, yes. I mean, that's the way it is. Antiderivative of each of these, right? So antiderivative 1 is u, right? Minus, okay, this one actually works out to be pretty good. This one's just u cubed. And then the next one is 3/5 u to the 5th. Just doing power rule on these, right? It's just power rule on each of these. Plus c. You have a question over here? No? No? You're good. Finally, we replace u with sine x, and we're done. So it is sine x minus sine cubed x plus 3/5 sine to the 5th x minus 1/7 sine to the 7th x plus c. Do we want to check it? No, I don't feel like checking that. If you take the derivative of this, right, you should get what? Cosine to the 7th, right? Imagine how much stuff cancels out, right, for that to happen. Pardon? Yeah, in some sense, all that first part stuff looks like it'll probably go away because the derivative, well, hold on, wait a minute. What's the derivative of this? If you just look at that last piece, what's the derivative of this? It would be sine to the 6th x and then times cosine x. So we need to be at cosine to the 7th. So yeah, maybe not. You see what I'm saying? Okay, so I mean, look, this is why the Cal 2 is so much different than Cal 1, right? Because, like, if I ask you for the derivative of this in Cal 1, we know chain rule, right? It's just systematic, go after it. What's the antiderivative of that? There's no way, nobody, including myself, can just look at that and just be like, oh yeah, sine x minus 1/3, you know? Like, no, that doesn't happen. I've never met anybody like that before, all right? Not to say they don't exist, I just haven't met them. So, you know, there's a systematic way we have to approach this. All right, sine to an odd, cosine to an odd, we have a method? Yes? Okay, so what's next? What if we have, let's do the second one there. Okay, so now we got sines and cosines, right? We got sines and cosines mixed up together. Do we have a sine to an odd? No. Cosine to an odd? Yes. So when we see either a sine or a cosine to an odd, we are going to be thinking, let's peel something off, all right? And in this case, because cosine is the odd one, I'm going to peel off a cosine, all right? And look, I'm hoping for the best, right? I don't even know if this is going to work. I'm just hoping for the best. All right, if I do that, can you tell me right now what my u is going to have to be if I do this? The part I peeled off is my du. So that means this is going to need to be a sine, right? This needs to be my sine. My du will be the cosine x dx, right? This is me just kind of like thinking. How do I think, right? That's me thinking. That's what's in my bubble of thought. Is that if I peel off a cosine x dx, then that means my u is going to have to be sine, right? And that means the rest of this has to be written in terms of sine. I can ignore that. That's my du. But that has to be written in terms of sine. The sine squared is already in terms of sine, right? But the cosine to the fourth is not. Well, that's OK. I know how to turn cosine to the fourth into sines using Pythagorean, right? So I'm going to rewrite this as sine squared x. And then cosine to the fourth, I'm going to write that as cosine squared x squared, and then cosine x dx. Right? I have to write the cosine to the fourth as cosine squared squared. And then I can rewrite cosine squared x as 1 minus sine squared x. So I have sine squared x out here. And then I have 1 minus sine squared x here, but then all of that is squared, but then I have cosine x dx. Everyone see it? Now, can I go ahead and get everything in terms of u now? Yeah, because I've got u, every sine is going to be replaced with u, and the cosine x dx is going to be replaced with du, and we'll be happy. Happy? No? That's a stretch, huh? All right, so here we go. Integral. What? U squared, parenthesis, 1 minus u squared, that whole quantity squared, and then cosine x dx, du. There we go. And as bad as that may look, this is just a polynomial, right? Ignore that u squared. Can you do 1 minus u squared squared? Yeah, you can figure out what that is. And then can you just pass a u squared through it afterward? Yes. Could we do the u squared first and then square it? No, order of operations, right? You got to do the exponents before you do the multiplication. So I'm going to square that first, then I'm going to pass the u squared through, and then I'll be on my way. Any questions while I'm erasing this over here? Okay, so I've got integral u squared. I'm going to do the squaring of that in my head. So 1 minus 2u squared plus u to the fourth. That's the same thing we did earlier, isn't it? Yep. Yeah, du. And then distribute the u squared through. U squared minus 2u to the fourth plus u to the sixth, right? Du. And now you're there, right? Just do each one of these. 1/3 u cubed minus 2/5 u to the 5th minus, plus, sorry, 1/7 u to the 7th plus c. That's just power rule. And replace all your u's with sine. We're done. 1/3 sine cubed x minus 2/5 sine to the 5th x plus 1/7 sine to the 7th x plus c. So I actually offer a Cal 2 online class, right? I'm not connected. Continue anyway. Yeah. I offer a Cal 2 online class, and I can always tell when they're not doing their own work and they're using a computer when I get to problems like this. Maybe I can show you if the internet works for me here. Come on, come on. You're not connected. Is the network down? What's going on? I may not be able to show you this. Oh, no. Yeah, it looks like the web may be down here. Oh well. Yeah, it looks like it may be down. No internet. Try again later. Okay, well, what I was going to show you is that if you type this in to like Wolfram Alpha or Symbolab or something like that, or any of those other programs, right? This is most likely not the answer you're going to see, because the computer will use all these like pre-cal identities to like simplify this into something that a human would never do. And so when I see my students give me that answer, I'm like, okay, yeah, right. You know, like you didn't do this, obviously. And you can't argue against it, because you can't, like, it's really hard to see the identities that they use. Like, it's really hard to see the step-by-step. This is a natural human answer to this problem, right? We do a U substitution, we get it to here. We don't try and simplify this. We leave it just like this. Okay, so far okay? All right, so what have we not done yet? We haven't done tangent secant, but I've only had you deal with things with odd, right? Every problem I've given you has either had an odd sine, an odd cosine, or here, you know, it was a mix of both, but the cosine was odd, so I was able to do this, right? Would the problem have changed at all? Would it have changed at all? Let me do it in blue. Had the sine been odd as well? What if that 2 would have been a 3? Could we still have peeled off a cosine? Yes? Would this have changed? Other than that, no, right? That'd be sine cubed. That would still be cosine squared squared. Down here, this would be what? U cubed. Cubed, right? Over here, this would be cubed, right? And then when we distribute through, every power would go up by 1, wouldn't it? So this would have been cubed, this would have been to the 5th, this would have been to the 7th, and so on and so forth, right? So you see, if they would have both been odd, we still would have been able to do this? Yes? Okay. So odd powers of sine and cosine, like, we're in business. We are in business. But what about if you have even? And just even, no odds, right? So we'll start out with the very basic example first, and then they're going to get pretty bad pretty quick. Like, the amount of work in this will probably take up an entire page. Writing sideways like landscape, it'll probably take up like a full page. Like part C that we do is going to take us a while, right? So the evens suck, all right? Just fair warning. Let's do sine squared x dx. Let's just do that one. Start simple. Okay, that's an even power of sine. So here's the thing. I can't peel off a sine. Let me just show you what would happen if I tried. If I peel off a sine, then what does that mean? So here's me thinking again. I like this little thinking thing. This is kind of cute. So what am I thinking here? U must be what in order for this to work for me? This is that's my derivative, right? That's my derivative. So the U must be a what? Cosine. And yeah, I'll have to worry about the sine, because derivative cosine is negative sine, but my U would have to have cosine in it, wouldn't it? This would have to be my du, and so that would have to be rewritten in terms of cosine. But I can't rewrite sine in terms of cosine, can I? Because it's not sine squared, is it? It's just sine. So I can't use a Pythagorean identity. You see that this wouldn't work, peeling a sine off?
You can do the square root of 1 minus cosine squared x.
You could rewrite that as what? Oh, yeah. You could. You could rewrite that. So you're saying take that right here and solve for sine? Okay, so that would be, sine would be what? The square root of 1 minus cosine squared x. And then du would be the sine x dx. Could we do this? Yes, I agree with you. I agree. We could, right? We could have solved for sine here, but let me show you why we're going to not be able to do this. Because if we did this, u would be cosine, right? This would turn into square root of 1 minus u squared. This right here is the derivative of cosine, but we're off by a sign, so I'd have a negative du here. I don't know, do you follow all that? Right? If u is cosine, derivative of that's negative sine, I'd have to scale it, so I'd have this. The problem is you can't do this because it's subtraction, but there's a root and you can't split it into 2.
Could you not do it to the power of 1/2?
Yes, you could do it to the power of 1/2, but you're still stuck. Because how do you do this?
Distribute the power?
Can't, no. That would be the same as taking the root of each one, right? So we're stuck still, right? And guess what? That's what Wednesday is going to be. This is what Wednesday is going to be about, is how do we do this? So we are going to be able to handle this, but we can't handle it yet, all right? All right, so there's no easy way to get sine in terms of cosine, right? Do y'all agree? Without introducing a root or something like that. Okay, so not really good. All right, so how do we do even powers? Well, we haven't used these yet, have we? Well, we used one. Did we use one earlier?
We tried.
We tried, but it didn't work, right? Because it made a 8x and we had a 4x, or t. Was it t? Yeah. But this will actually work pretty good now, because if I turn my sine squared into this, let's just do that, using the power reducing formula, this integral becomes 1/2, super nice, 1 minus cosine 2x dx, right? That's just using the power reducing formula straight away. I can pull the 1/2 out of the integral. I won't put it in parentheses. And now you have something very nice and clean, don't you? Can you do those separately? Yeah, antiderivative of 1, x. Okay, this is what I started class with. We should be able to handle the antiderivative of cosine of a linear expression, right? So we should be able to do that. Yeah, go ahead and finish that up. I'll come write the answer here in a second. Let me see, what do I do? Energy saving, would you like to keep the energy saving countdown? Keep it on? Not this session. All right, so this becomes 1/2, okay, parenthesis, antiderivative of 1 is x minus, so I'm bringing the minus here, and then I'm thinking to myself, what's the antiderivative of cosine of 2x? It is 1/2 sine 2x. So 1/2 sine 2x, and then plus c. How do we know that? Because we've talked about it before, and today is, well, we talked about it in the beginning of class. So I cover up that minus and I just figure out what that is. If that would have turned out to be negative, I would have had to double negative and then it would have been a plus. And I can just leave it like that or distribute the 1/2 through. I'll put the 1/2 through, just for fun. 1/2 x minus 1/4 sine 2x plus c. Okay? So if we have an even power, are there any questions? I see some looks of yes.
So when you pull the coefficient out from the
Yep.
integral, you always distribute it back in?
You don't. You could have left it out here. This would have been fine. But you need to have it there.
So it's just not on the front of the x, right?
It's not on the.
It's outside of the parentheses.
Yeah, it's outside of everything. Yes. That didn't seem so bad, right? Even power didn't seem so bad. Let's do part C. Cosine to the 4th. Does anybody else have a question on this one? Beta t dt. Ugh. No? No questions on any of this? All right, unfortunately, for the same reason as I explained with the previous problem, you can't just peel a cosine off here, right? You can't just peel a cosine off. And Chris, even if you did here, right, if you peel the cosine off, you would have cosine cubed now, right? So how do you use the Pythagorean to get cosine cubed, right? It would have to be solve for cosines to get a square root, but then cube it. So it'd really be raising it to the 3/2, and I mean, so next class we'll address that. We will be able to handle it, but just not yet. All right, don't let the beta t scare you, right? The beta t is just a constant sitting in front. We don't know what that number is, but we do have to keep track of it the whole time, right? All right, so we can't do any peeling. So how about this identity? Can we use this identity? Do you think we can just say, oh, change that to a 4, change that to a 4? Nope, can't do it. But we can look at that as being this squared squared, just like we did before. So this is the same as cosine squared beta t, all of that squared dt. And now the part that's on the inside can be rewritten as 1/2. We got to make sure we get our parentheses right here. This is going to be okay. It's 1/2. We're doing cosine this time, right? 1 plus cosine of, so on this right here, I'm using this formula, but we have beta t here instead of x. So it's 1/2 parentheses 1 plus cosine of 2 times beta t. So this is going to be 2 beta t. I'll put in parentheses. 2 beta t. Okay, close the parentheses, squared dt. Okay, so everything in blue here, everything in blue there is this formula being applied on this, right? But with beta t instead of x. You all right with that? Okay, we've got to square that, don't we? We've got to square that. Now, what I like to do in this case is, do you all see that we have multiplication of this 1/2? And it would be nice if we could bring that 1/2 out, right? But you can't because it's got to get squared first. So when you square the 1/2, it becomes what? 1/4. Why can I do the squared on this and we couldn't do it earlier? Because they're being multiplied, right? So the squared here, I get a 1/4. Let me just write what the next line is. I won't pull it out yet. I just want everyone to be clear on what we're doing algebraically. So we're applying, because we have multiplication right here, right? There's multiplication right there. I can square this and then square this. And that's what I'm doing, squaring each one. Now the 1/4 comes out. Integral. And now I have 1 plus cosine of 2 beta t, that whole thing squared dt. Any ideas of what to do now? Square it. Let's square it. Let's square this. Let's do this times itself. Okay? And I'll do that right here, scratch work. What's 1 plus cosine of 2 beta t times itself, 1 plus cosine of 2 beta t. Right, all this stuff? What would I get? Let's see. I'm going to just put the answer here. What is it? 1 plus 2 of the cosine of 2 beta t's, that's the middle pieces together, plus, yeah, this is the cosine times itself again, right? So cosine squared of 2 beta t, right, like that? All of that dt. Okay, so this was 1. Then I had cosine 2 beta t, and then plus another cosine 2 beta t. That gives me 2 of them. And then cosine of 2 beta t times cosine of 2 beta t is cosine squared of 2 beta t. We having fun yet? We've split it up into 3 terms though, right? Okay, can you find the antiderivative of this? Yes. It's with respect to t, right? So the antiderivative of 1 would be t. Okay, good. We can handle that. How about this one? Forget the 2. That's cosine of a linear expression. Can you find the antiderivative of cosine of a linear expression? Yes. We have a formula for that as well, right? Started class with that. Good, good. Cosine to an even power. How do we do cosine to an even power? We got to do this again. We got to do this again to power reduce it down. So we're in the middle of a problem, right? We're in the middle of a problem where we had to use the power reducing formula. And when we worked it all out, one of our pieces requires another power reducing formula to complete it. All right? So it's kind of shitty, but you know, this is the way it is. So let me do this. How do I want to write this? Because we can handle some of this. Let me do this. This is, how do I want to do this? I just want to be done with this. Or I can go work this out as its own problem. Totally up to me. Let me do it this way. Stick with me here. See how this works for you. Okay, all I did there is distributed the 1/4 through. I just pushed the 1/4 through. The reason I did that is because now I'm going to get the answer for this and the answer for this and then set up this new integral next to it. That's going to be here. So this is equal to, okay, the antiderivative of 1/4 is 1/4 t. All right, I need to find the antiderivative of this right here. Let's forget the 1/2 for now. What is the antiderivative of that? So you have to scale, right? What do you scale by? 1 over 2 beta, right? And then we're going to have what the antiderivative of cosine is, sine? Okay, and we had a 1/2 in front. So I'm going to put plus the half that we had in front. Then I have to scale by 1 over 2 beta. And then we said it would be sine of 2 beta t, right? So, I mean, you have to be comfortable with this at this point, right? You have to, well, at least understand what I'm doing to get from here to that piece over there. So what's in blue there when I took the antiderivative is what that is, right? Plus this integral, right, which I don't know how to do. So I'm going to write it like this. Plus 1/4 integral of cosine squared of 2 beta t dt. Okay, I'll pause for a second. Any questions on where I am, how I got any of what's on the board there? No? All right, now I'm focusing my attention on this, right? And I'm going to use this formula right here Cosine squared, but instead of x, what do we have? 2 beta t, right? So this is going to turn into another 1/2, a parenthesis, 1 plus cosine of twice 2 beta t. What's twice 2 beta t? 4 beta t, right? 2 times 2 beta t is 4 beta t. So let me do it. This is plus 1/4 integral. I haven't taken the antiderivative yet. I'm just using a pre-cal formula here. 1 plus cosine of 2 times that is 4 beta t dt. And then I can take the 1/2 out. 1/8 integral 1 plus cosine 4 beta t dt. And now can you do each of those separately? Yes. Those you can handle each one. The antiderivative of 1 is t, because our variable is t. And now plus, okay, cosine 4 beta t, we've done this, right? Cosine 2 beta t, we've done something like this. I will have to scale it by 1 over 4 beta sine of 4 beta t, right? That'll be my antiderivative. And I just need to remember now I can finally throw in my plus c because I have no more integrals left. So all of this, right, I was just working this down. Boom, 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 boom. I still have all that out front, don't I? Okay, so I'm ready to start putting together a final answer. See if I can fit my final answer right here. I have 1/4 t. I've got plus, okay, that's this. These multiplied together is 1 over 4 beta plus 1 over 4 beta sine of 2 beta t, all right? So that's just this and this. And now this. And I'm going to go ahead and distribute my 1/8 through. So 1/8 t plus 1/8 t and plus 1 over what? 32 beta on the bottom, sine of 4 beta t, bless you, plus some constant. One more step. I can combine what together? The t's. I have 1/4 t plus 1/8 t. That's 3/8 t. So 3/8 t plus 1